Hello, this is an introduction to productivity, and we're going to be looking at the Heiser and Render problem from Chapter 1, problem 1.1, and we'll take a quick look at 1.5 and 1.11. Productivity is simply the outputs divided by the inputs. It's actually a very common measure. One of the most common examples probably is miles per gallon in terms of what you would use productivity measures personally. Let's look first at this original productivity, which is simply boxes divided by hours. 120 boxes divided by 40 hours. You could do that in your head, but we're setting ourselves up to be able to do much more advanced productivity calculations and analyses in the future. So in Excel, this would, you start the formula with the equals, and then there's two ways that I can put my cells, my target cells in there. One is I can just click on them. So I click on B10, so that's the outputs, and it's divided by the inputs, which is here in B12, but another way I can enter them is just to type in the numbers, B12. And so that is the formula, B10 divided by B12. That's the formula for the original productivity. In the second part of the problem, we have a new output. So through a process improvement, the team is able to reach 125 boxes produced in a day with the same 40 hours worked. And so we've got new productivity, and that's equal to B16 divided by, and it's the same input as before, B12. So we have a new productivity of 3.125. So the productivity increase is obviously the new productivity minus the old productivity. It's 3.125 minus 3.0, or 0.125 boxes per hour. Productivity increase will be in the units of productivity. So to get Excel to do that, we're just going to have the new productivity, B19, minus the old productivity, B14, and that's it, 0.125 boxes per hour. The percent increase, there's really two ways we can get at that. One is to go through it bit by bit, and I'll put parentheses here. So we have the new productivity minus the old productivity divided by the old productivity. Okay, so we have a formula that works. This is the correct formula. We have the original, or the new productivity minus the original productivity, that quantity divided by productivity, and we have it in percentage. If your numbers aren't in percent, then you can go up to the toolbar and click the percent on the toolbar, or you can just sort of force it there by multiplying the whole number by 100 to get it to percent. Now, you could also, I always like in Excel to look for shortcuts. And you already calculated the productivity increase. So we also could have calculated this like this. So equals B21 divided by original productivity, B14. Boom. Same number, and it's the same calculation, but you're just taking advantage of the fact that you already calculated that unit productivity increase. So we've calculated productivity, new productivity, calculated what the productivity increase is, and then turned that into percent. Now in the next problem, you're doing the same thing. Your outputs are balls produced, and your inputs vary. So you can calculate what is essentially a labor productivity, which would be over here in C11. Resin productivity, though I'm missing a resin input there. Capital productivity, which I did for you. or an energy productivity. You could sum all those up and have a combined productivity, but I didn't require that in this problem. And then you have a new productivity. Then in each case you'll have a productivity change, which will be the change in productivity. So new productivity minus old productivity divided by old productivity. And you see that example there. And then finally 111, oh, it's very similar to 1-1. So I don't think you'll have a problem in calculating those as well. Good luck. Productivity calculations are used in a lot of different areas. And I'm going to show you how to sort of streamline Excel when we meet, when we next meet.